Good morning, Matt Roscoe here with our course Math 301 and a short video lecture to replace myself during my absence. What I want to do today is introduce to you the first project in the course. You can read more about the project's general description in the syllabus and how much they count towards your grade, but you can generally think of projects like they take the place of a test or assessment in the course across the semester. There'll be 3 of them. So the first one is available now for your inspection. It's under communication and documentation on our Moodle page. If you go there and scroll down to the bottom, you'll see that there's a few things that have been added. The projects folder, as well as an assignment for project 1, which is obviously on statistical problem solving. Let's go ahead and dive right in and see what the problem statement looks like on the project. So I'll bring it up for view. Maybe. There it went. So here's what it looks like. It's got a short 1-page description. It says the GAZE 2 document identifies 4 aspects of the statistical problem solving process. There is formulating a statistical investigative question, collecting and considering data, analyzing the data, and interpreting the results. In our course, you've learned how to use technology to visualize and produce statistical measures of data, both in univariate and bivariate settings. Your task in this project is to engage in the statistical problem solving process while showcasing your ability to use technology to aid your analysis of the data. So here are the tasks. There are 4 tasks. The first one is to formulate a statistical question. Would you provide, please, a brief introduction to your area of interest, and then write a statistical question associated with that area. Finally, briefly justify why your question correctly falls under the category of statistical investigative question. So it should anticipate some variability. The second task is to collect and consider the data. So describe your data collection process. Where did you find your data? Is the data sample from a larger population? If so, describe the sampling methodology. Is there any reason to consider bias in the data that you have collected? And does the data collection process impact the scope of generalizability? Are there any limitations to the analysis or interpretation? So it is possible that you might go and collect data, measure something out in the world, and so please carefully describe how you collect that data in the world, and consider the potential bias or biases that are introduced to the data through its collection process. Many of you, I would assume, would probably collect data from some data repository on the web. If that's the case, then please tell us where you got it, some sort of a link, and then try to learn as much about whoever collected the data as possible. How was it collected? Where was it collected? And is there any reason that it might be biased in its collection? So collect and consider the data is the second task, and make sure you make that, I guess, include that section in your report. And then, of course, the biggest piece will be the analysis of the data. Here's where I've double weighted the point value for this section or this task. So in a quote, when we analyze data, we seek to understand its variability. That's from the GAZE 2 document, which we've all read. So use technology to explore, describe, or compare variability in the data distribution or distributions if you're comparing 2 sets of data. And then use technology to create visual displays. Use technology to compute summary statistics, and then provide a summary of the results of your analysis. Your effort here will be assessed from 2 standpoints, so appropriate use of statistical analyses and appropriate use of technology. So I'll view it using 2 different, I guess, lenses. And then the last thing, of course, is to interpret your results. Once you've carried out all this analysis, you should sit down and write up what it is that you've learned and justify what it is you think, I guess, you've learned, and how to answer your statistical question posed in the, I guess, task 1. So use this statistical evidence from your analyses to answer your statistical question, and consider limitations to your study due to any sampling biases or outlier effects. So that's the idea. Just engage in the statistical problem solving process and document it using a sort of a report written in 4 sections, and paying it special, I guess, attention to the analysis of data using technology. So showcasing your ability to do that. So I wanted to give you a little bit of a sense of, well, what's something you could do here. And I thought to myself, what would be an interesting question for me to ask that would be informative to me as a person, or someplace in my past, or an interesting issue that I have right now that I'd like to know more about. So here's what I came up with. Um, I was thinking a little bit about rivers, and I'm a big river sports fan, whitewater kayaker, and we own a raft and do a lot of raft camping with my family. So I'm constantly looking at river flow data, and one of the things that came up was this idea of 1997, when I had recently moved to Missoula. I thought I had pretty much died and gone to heaven. The winter of 96, 97 was one of the heaviest snowfall winters that we've had in my time living here since I moved here in the fall of 1996. We got 21 inches of snow on Christmas Eve, and we were cross country skiing on the Riverbank Trail for a couple months. But even more exciting than that to me, I mean, I love winter sports, but the spring runoff was some of the highest flows that we've seen in the rivers around Missoula, at least in my lifetime. And I just happened to be here for it, recently arrived. And so one of the places that we go a lot kayaking is the Lochsaw River. This is a river that flows in Idaho, but we are the closest, I guess, major metropolitan area to the Lochsaw. It's over Highway 12. The Lolo Pass road takes you there, and if you've never been over there, I'd encourage you to go. It's a beautiful river, and it has extremely high water because that pass at Lolo gets a huge amount of snow every winter. Anyway, I happened to be on the Lochsaw when it peaked in 1997, and it's some of the biggest whitewater I've ever kayaked in my life. And so I kind of had this question of how different was the high water during the 1997 spring runoff on the Lochsaw. So that would have been my statistical question. It definitely anticipates variability, and what I want to do is sort of compare it to historical averages. One place to go, I've added to, if you're interested in a question like this, I've added to the data repository wiki this hydrological data stream flow conditions that USGS makes available. So if I go there and show you where we can get data, this is pretty neat. So this is current water data for the nation. It's color coded here by percentile. So the flows are ranked against all of the flows for this day in history collected over the lifetime of each of these locations, many of which have 50 to 60 year lifetimes. So it says only stations with the last 30 years of records are used, at least 30 years of records. So in other words, each one of these stations has at least 30 years of records for today's date for stream flows, and you can see how today's stream flows vary compared to those 30 years of record. And it's pretty obvious right now that the West is experiencing drought. We can see quite a bit of red in here and orange, which means extremely low percentile ranks compared to the 30 years minimum data that they have to compare. The central United States looks like it's roughly in the range of normal, and New England, as well as some of these areas down south, are experiencing extremely high flows in the blue color there that we see. Perhaps the effect of some of the hurricanes that we've seen recently. So you can click anywhere on this table and it'll take you to that state. So I'm going to click here on Idaho because I want to go to Idaho. I'm going to click on it again to go to a larger Idaho map. And these are all the stream flow location data monitoring sites in Idaho. And I just know from experience that this one right here is the Lochsaw. So I'll click on the Lochsaw and it'll tell me what it's doing right now. Right now there's only 314 cubic feet per second flowing in there. That's tiny. It's in the 11th percentile, meaning it's extremely low compared to flows on this date across the lifetime of the data. But one place that you can go to is you can go to Stream Gauge Inventory, which will take you to an inventory of all of the stream flow data for that site. This is the place I typically go to to take a look at, I guess, what's going on the Lochsa when I consider going over there in the spring. And I look at current and historical conditions. So right now what you're going to get is you're going to get a graph here that's showing, you know, about the last week of flows over on the Lochsa. There's a little bump up there, it looks like, a couple days ago. Maybe there was a little rain. And then these little triangles up here, that's the median flow. And it's based on, it looks like 93 years of data for each one of those days. So, you know, we're below the median flow, and there'll be statistics down here, and it'll sort of place it in percentile. It says, you know, most recent flow is 314. It's in between the minimum, which was recorded in 1988, and the 25th percentile data, which was 364. You can see the median for today is about 431. So it's a little bit low, but I guess not extremely low, but definitely worrisome. We're in a drought situation right now. So where can I go to get other years' data? Well, you can go to you know, daily statistics to look at any daily statistics from any time period you want. So if I go to daily statistics, I have to first click on discharge in cubic feet per second, and then put the year that I'm interested in. You can see I've done this before because it's auto loading, but 1997. And I'm going to go from 4/1 to 6/30. So it's April, May, and June are what I'm defining as sort of the runoff months. So I'm collecting just those 3 months data. The reason I do that is because I'm really curious more about just that period, that, you know, from when things started ramping up and then high flow and then started coming back down. So I'm making that choice in the data. I'd have to explain that in my data collection process and my rationale. When I go ahead and get that in there, I can submit, and what'll happen is I'll get a table of discharges for the Lochsa for April, May, and June. You can see it's from the 96-97 water year, and so yeah, that's the table of flows. And I don't know, it's just scrolling through the flows, my sort of eyeballs were knocked out by that number right there. I'm pretty sure that's the day I was over on the Lochsa in 97 at the peak high flows, and it was near 30,000 CFS, so which is extremely large for that river. But you can see that things sort of came down, and then it looks like they ramped back up again in the 20s, and then came down, it looks like, for good after that. So there was some fluctuation, up, down, it looks like, just perusing the data. So of course what you can do with this is sort of cut and paste into Excel fairly easily by just highlighting cells and then massaging in Excel to get the columns that you want. Let me show you how I got something to compare it to. So what I really want to do is compare this data against historical averages. If you just delete these and let it carry out the historical average across all data and submit again, you get this set of table, and the table here says, well, that's the historical mean of daily mean values for each day for water years on record in cubic feet per second. The period is from 1910 to 2021, so it gives you a sense of sort of what the Lochsa does on average across 93 years of data. And of course we can again copy this and paste it into Excel and use this as comparative data for the 97 flow year. Hope that makes sense. So what I did then was, of course, go to Excel, and what I did first is I just put all the flows into one column, and I put date as another categorical variable. And you know, I have flows that are related to historical flows on those, turns out to be 91 days. So I think it's 91 days. Yeah, there it is. And the 92nd row is where historical flows end, and then the 93rd row is where 97's flows start, and then of course end somewhere in the 180s, 183. Yeah, 183 will be the last few 97 flows. So the reason I did that, or laid it out that way, is I'm anticipating using CodeApp. What I want to do is I want to have sort of a dot plot of flows for both the historical data and a dot plot of flows for the 97 data, and this will allow me to do a stacked dot plot like I showed in class the other day. So I'll go ahead and copy. Let's see, what am I doing? Sorry, go back up to the top, holding shift down, holding shift, watching me. There we go. So I've highlighted all the data. I'll hit Control C for copy. Didn't work. One more try. Control C is copy. It's being a bugger, sorry. There it goes. Now I have the copy, and I can now dump it into CodeApp. So let's pull CodeApp down into the page and launch it. And I'll create a new document. I'll go to Tables, New, and I'll import case data from clipboard, and there I have it. And of course, now we can start a graph where we pull down flows into the x-axis. Let's make this a little bit bigger so it's nice, easy to see. And if I put date in the y-axis, it'll split those out, and right away we can see quite a bit of difference between the 97 flows and the historical averages for the same time period, the 3 months of the high water runoff. And it would be kind of fun then to carry out some statistical analyses here. I think I'm going to increase my point size a little bit just so I can see it a little bit better. I don't know, change probably color here, like blue. I'll go ahead and do a little bit of mean comparison. So how did the centers differ? So it looks like the mean for 97 was about 12,000 CFS, whereas the mean for the historical mean's about close to 8,000 CFS. So about, I don't know, a difference of some 4,000 or 5,000 CFS on mean flows. Let's see how medians compare. I'll turn the medians off. So median about 10,000, 11,000 here, about 7,600. So again, 3,500, somewhere in the neighborhood of their difference in median flows. So we have a good sense that definitely the 97 runoff season was higher on average by quite a margin, 3,000 to 4,000 CFS higher on average. We can definitely see that the highest flow at 29,000 on 97 was much higher than the highest flows, looks like in sort of the 11,500 range, somewhere in there. So the extremes were much higher as well. But let's take a look at how the spread is different. So standard deviation, just a gigantic difference in variability. The standard deviation on a normal year is somewhere in the neighborhood of 2,700, whereas the standard deviation in 97 was roughly double that, somewhere in the neighborhood of 7,000. So just a huge difference in variability. So we saw much more variable flow in 1997 and a higher flow on average based on the standard deviation. The MAD should back that up, and so should the dot plot, right, which would show an IQR that, you can definitely see that the IQR here for 97 was at least double what the IQR is here for the historical averages. So I think this is a pretty convincing presentation that 97 was a really abnormal year, and we can quantify that both by comparing centers and comparing spreads of the two distributions. Hope that makes good sense to you. One thing that I was interested in is whether or not I could somehow do some sort of bivariate work with the data that I had. So I played around with it a little bit, and here's what I came up with. I decided to take a look at how, if I call these days, the 91 days over which I'm basing my comparison, these 3 months, April, May, and June, then what I can do is I can put a day 1 through 91 and have the historical flows, so there they are, and then another day 1 through 91 and have the 97 flows over here. So now I have 3 columns of data instead of just 2, and I'm going to show you what you can do to sort of get a sense of how to plot this as a time series data, so some sort of a time series version here. Let's see, not Tinkerplots, but CODAP. There it is. So I'm going to go ahead and undo that and click on here and add this new import case data. Now we have, no, that's not it, just 2, I want 3. There it goes. So I copy that. Let's see if I can get it in. Well, it's being a bugger. Let's try it again. Okay, got it. There it is, 3 attributes. I'm okay now. Okay, interesting, it rearranged it to put the categorical data first, but I'll go ahead and pull up a graph, and what I'm going to do is I'm going to put day on the horizontal axis, and then I'm going to put flows on that axis, and now you can kind of see just a time series graph where it's sort of a bivariate study here, where we're looking at day for the x-axis and the flows for the y-axis, and I think you can tell that this would be historical, and these ones hovering over are the 97 flows, but you can actually drag that date along there to get I guess a categorical variable that will color code and change the color associated with the 2 sets of data, and now you have a pretty good time series data that definitely makes the case that things in 97 were really different. I thought it was kind of interesting that things started out actually below average here, but then bumped up. We came back to average here, and then huge spikes that were much higher than average, and then we're kind of back down into the range of average here. So definitely between sort of, I guess in this region especially, we're seeing flows that are really abnormally high, and of course there's the big day 29.2, but another peak at day 62 is came close to coming back to that high flow 24.4. Anyway, I feel like this gives you a good sense of the type of analysis that I'd be expecting from you. So using CODAP to visually display your data. If you have 2 univariate settings, then I would expect nothing more than side-by-side univariate, or maybe it's just 1 univariate setting, some sort of univariate analysis, centers and spreads. If you do have data that makes good bivariate, for a good bivariate study, then definitely go for it, use it, and display a bivariate data display, something like this. I would say this is really better termed a time series graph than a bivariate graph, but of course there are two variables, day and flows, so I guess it falls into bivariability. And that's it. Once you sort of have a good sense of your analysis, then you need to sit down and write your conclusion. So for me, the conclusion would include some sort of statements about how quantifying how different 1997 was in terms of average flow, variability of flow, and extremes of flow. I think I would probably include discussions on all of those and back them up with numbers extracted from my analysis. And then talk a little bit about limitations of my study. I guess we could say things like I think it's fairly good measurement of what was going on over there during those 3 months. The USGS is pretty reliable, but keep in mind that each one of these dots is a daily average, so it's possible that flows at a specific point in time were higher or lower during the day. So we sort of have an average for each one of these points of daily flows. So I'd probably address that a little bit and then talk about any limitations of the study. I mean, one thing to keep in mind is that because this orange graph is the average of 93 years of data, that this includes extremely high flows and extremely low flows in it. So it's sort of a nice thing to compare against. But if we were to compare 97 to say 98, we wouldn't see nearly as, I guess, nearly as uniform a flow distribution. In fact, the river itself, I think, has quite a bit of variability in flow year to year. So one question might be interesting to ask is how much variability is there in this data, for example? That might make it a little bit less convincing that it was extremely different in 1997. So I hope that gives you, I guess, some sort of an overview of the type of analysis I would expect you to carry out and the kind of conclusions and answers you would draw. And that's about all I have for today. If you have questions about the project, I'd ask you to bring them to class on Monday, and we'll discuss it. I'll make sure and make time for any questions that you might have about project number 1. Okay, I'll talk to you soon, and I look forward to gathering as a class again on Monday.